1 that I said, the similar data items, about the similar data items. If a data item X is close to the mean, then it is more similar to, we can say that it is more similar with the other values. Or if a data value X is far from the mean of the normal distribution, we can say that it is less similar with the other values. And with this observation, we measure the data similarity between two data similarity with integral area of the normal distribution. This means that if the data is near the mean, it has high scores, and if it is far from the mean, then it has low scores. Next, we use the provenance similarity to adjust the score. First, we model the provenance similarity with a graph theory. As I already said, we model the provenance as a subgraph of the it can be a path, it can be a tree, or it can be arbitrary graph. There is some popular method to measure the difference between the graph. Here we use edit distance between two graphs to measure the difference between two provenance, and we call it as we make a function for measure this similarity, and then this reflects the table that I show in this page. Then remember that the data has a similar provenance, but the different value, the trust score should be decreased, and if the similar data value but different provenance, we need to increase the trust score. Yes, then we adjust this. We adjust the trust score with the same normal distribution model. Here, if the data has some different provenance from the other data, then we move the data point to the center of the normal distribution. And if it has very similar if it has very similar provenance but has quite different value, then we move the data point to the outside of the far from the center of the normal distribution. And after that, this is the and then finally we calculate the trust score with the adjusted data point instead of this point only calculated from the data similarity. Okay. Then with this model, we generate the intermediate trust score based on the history data, and from the cross-check with the data from the other sensors, then we can evaluate the trust scores of data items and network nodes. Now we need to think about the performance of this cyclic framework. We can think about two approaches for incremental evolution of the trust score. As I already said, there is we need a cycle to calculate the trust scores. Then in the intermediate node, we compute the trust scores whenever a new data item arrives. It means that the cyclic computation should be conducted for every new data items. And the advantage of this approach is it can provide high accurate trust scores without delay. But it incurs heavy computation overhead. Thus, it is not feasible when the arrival rate of data items is very fast. Let's think about this. If the data item arrives, if 1,000 data items arrives within 1 second, then it means that we compute all things all things 1,000 times within one second, then it is not feasible in large-scale sensor networks, or sensor network has very fast input rate. And the alternative approach is the batch mode. In the batch mode, we accumulate a certain amount of input data items and then compute trust scores only once for accumulated data items. It means that we do not conduct the whole computation for each data items. We just do that with a set of data items accumulated in certain time period. The advantage of this approach is it can reduce the computation overhead, so as to make the cyclic framework scalable for over the input rate of data items and the size of the sensor networks. However, there is a disadvantage, critical disadvantage of this approach. The accuracy of the trust score can be very low compared to the immediate mode. In this approach, we need to wait to accumulate some data items. Possibly it can be on 1 minute or 1 hour or 1 day. Then actually we do not know what happens during the period. Probably some sensors becomes inaccurate, or some sensors can be attacked within the time period, but the system still used the previous trust scores, previous conditions. Okay, in this example, in the intermediate mode, this computation should be conducted for each data item. But in the batch mode, only the step 1 is conducted for each data item. It means that we calculate the current trust score of the data item based on the current trust score of the node. The score does not change until we conduct the computation in batch mode. Then the important thing is when we calculate the trust scores in batch mode, 1 hour or 1 day or 100 data items per 100 data items or per 1,000 data items. Actually, it is not a bad choice, since the static time period or static number of data items does not mean anything about the current status of the sensor network. And then we use a smart method for this one. Okay. In the batch mode, there is 2 stages. First one is the store stage. It means that we only conduct the current trust score based on the current node score. And the second stage is evolution stage. And in this stage, we calculate the trust scores with the cyclic framework. And then the evolution stage is triggered when a threshold is reached. As I already said, using a static number or static time period is not a good choice. Then we use a confidence interval concept to trigger the evolution stage. And this means with the same statistic model we used for data similarity and provenance similarity. In this concept, the one advantage of this approach is we can only conduct the evolution stage only when the current sensor network stage is significantly changed from the last evolution. Okay, for this we use a confidence level gamma as a threshold, and then whenever a data item arrives, we only calculate the mean of the data value with the historical data, and then we check how much is different from the previous mean, and then only the current mean is outside of the confidence interval. Only in this case we calculate